Welcome, my name is Zoeppig and today I would like to introduce you to our paper Follow Me, Confirmation-Based Group Navigation in Collocated Virtual Reality that I have written together with my colleagues Anton, Ephraim and Sebastian and my supervisor Bernd Froehlich. This paper was mainly motivated during a research project in collaboration with the Goethe National Museum in Weimar. And one use case that we explored in more detail was having a collocated virtual reality experience within the museum that allows to conduct guided tours through a digital twin of this museum. And one of the key questions that came up in this context was, how can a guide now lead a group of visitors through the virtual museum? And of course, one logical solution to implement is a group navigation. If we look at group navigations in virtual reality so far, we usually have a navigator who's responsible for planning and performing the navigation. And once the navigation is executed, the whole group follows instantaneously to the new location. In contrast, if we look on guided tours in real museums, then what we can usually observe is that we have a guide who's done explaining about one exhibit and moving on to the next one. And while a part of the group will follow instantaneously with the guide to the new exhibit, some will stay behind at the last exhibit, looking at it in more detail, for example, to gather more information. And we thought this should be supported in our VR application as well, and therefore ask ourselves, how can we enable more user autonomy within the group navigation? Therefore, we introduce an approach with a two-phase navigation based on a teleport, where the navigator can teleport ahead to a new location. We call the region of interest, and the passengers or visitors can basically stay behind at the last exhibit and follow at a later point in time. And this approach introduced two challenges. So if we have a collocated setup with this two-phase navigation approach, then we will introduce temporal spatial desynchronization that we have to account for. And also we need some confirmation mechanism to determine when should the visitors now actually follow the guide. To counter the spatial desynchronization in phases, we decided to use ghost avatars. They are basically getting activated whenever a user is at a different region of interest than I'm currently at, showing me their actual physical position in relation to me. And the idea is that we mitigate collisions between users using those avatars, and that we can support the social presence by always having a visual representations of the users in the same tracking space. For the confirmation mechanisms, we introduced three different techniques, basically shifting the control over when to follow between the different user roles. And we also implemented a baseline technique that we used later on for our study. The first technique basically gives the control to the guide. So here the guide has the authority to decide when the whole group should follow to the next location. And this is done with our little confirmation object, which is a floating sphere in front of the guide that can be touched whenever the group should follow to the next position. The second approach is vice versa. So here the authority is with the visitors, and the visitors can decide on their own when they want to follow, and therefore each visitor has their own confirmation object that can be touched whenever they're ready to jump to the next position. And the third approach is then a mutual confirmation between guide and visitor, and this confirmation is done by shaking hands between the visitor and the ghost avatar of the guide. Our baseline follows the common group navigation. That means once the guide is teleporting to a new location, the whole group will follow instantaneously. To make sure with all techniques that the navigation can be well understood, we also implemented pre- and post-travel feedback based on previous work. So on the one hand, before you're getting teleported, you will have a label attached to your right hand telling you that you will be teleported soon, together with a ray emitting from the hand towards the next position. And at the next position, you will see a highlight for the region of interest you're getting teleported to, together with a ghost avatar showing you your exact position where you will end up. And once the teleport is actually executed, you will also see a particle trail following you from your last position, so you get better understanding where you just came from. Our user study was then performed in a within subject design with 24 participants that we divided into 8 groups with 3 participants each, plus the conductor who would then do the study as a group. And the groups would do 1 guided tour per condition, which always started with an explanation and test phase, where the conductor would explain how the technique is working. And then the tour was going along 5 regions of interest through a virtual museum, resulting in 4 teleports. After each teleport, the users were asked to do a direction estimation, so basically pointing in the direction they think they just came from. And this was for us to get an understanding how well the orientation is. The second task was then a little assessment task where we had those vote boxes in front of the exhibit with 2 possibly fitting objectives. And here the idea was to get the users to walk around so we could test how well the ghost avatars mitigate collisions. After each condition, a questionnaire was filled out, and after all conditions were done, we also had a semi-structured group interview together with the participants to get some feedback on the techniques. For our analysis, we had 4 hypotheses, the first on spatial orientation and navigation understanding. And here we just thought that since we used the same feedback mechanisms for all techniques, there should be no significant difference between the conditions. The first indicator for this was an angle mismatch, which we computed during the estimation task. And here we found no significant influence and also very low angle mismatches, which is also possibly due to the particle trail that was shown after a teleport. Together with the results from the questions on orientation and navigation understanding, where we also did not find any significance, we got to the result that we cannot reject our first 2 hypotheses. The third hypothesis was then on the preference of the techniques, and here our general assumption was that the higher the autonomy, the higher the preference, and since user confirmation has the highest autonomy, we thought this should be significantly preferred over at least the baseline technique. Our ranking in the end then showed that user confirmation actually had the highest average ranking, which was also significantly higher than the baseline, and it was even higher or significantly higher than the handshake technique that we introduced, and therefore our third hypothesis can also be accepted. The last one was then on social presence, and here previous work has shown that physical interactions between users can result in higher social presence, and therefore we thought that the handshake should have the highest one, which was not shown by the computed presence scores, but during the interview in the end, 21 out of 24 participants mentioned it to be the most social technique. And yeah, since we did not find any significant difference, we rejected this hypothesis. At the end, I quickly want to go over some key findings. The first one being that the autonomy during the group navigation was preferred in our scenario, with user confirmation ranking the highest. For the future, we think that user and guide confirmation should be combined to also give some authority to the guide, for example, to keep a tour within a certain time limit. Also, both techniques were reported to be easy to use, which is good for novice users that might occur in the museum context, and also both techniques should scale well with larger groups, since they only need individual interactions and not between users, which is one of the reasons why we think that the handshake is not suited for this scenario. So yes, it was very social, but it requires a lot of coordination between the users, and some also mentioned that since they're rather introvert, it was uncomfortable to shake hands with a stranger. And finally, we could show that ghost avatars also in our setup counter spatial desynchronization successfully, so we did not observe any collisions between users, and we also got comparable social presence scores between the 2 phase approaches and the baseline, But we also got the feedback that the ghost avatars got confusing once you would see a lot of ghost avatars and real avatars, which made it hard to understand who is who. So thank you very much. And one last thing I want to mention is that we made the code for our studies and our techniques publicly available, and you can find it under the shown QR code. Thank you very much and goodbye.